Voyager 1, launched back in 1977, is still the most distant spacecraft humanity has ever sent from Earth. Right now in 2026, it's racing away at about 38,000 miles per hour. That's roughly 17 kilometers per second, and sits over 15.9 billion miles from us. Yet, incredibly, we can still send commands to it and receive precious scientific data. So how on Earth, or rather, how in the cosmos, is that even possible over such insane distances? And how much longer will we stay in touch with this legendary pioneer? Let's find out. Fun fact: Voyager 2 actually lifted off first on August 20th, 1977. Voyager 1 followed about 2 weeks later on September 5th. The two probes are nearly identical twins in design. Their original mission? To explore the giant outer planets beyond Jupiter using a once-in-a-lifetime planetary alignment that let them steal speed from gravity assists. Jupiter, Saturn, Uranus, and Neptune were perfectly lined up, an alignment that won't repeat until the year 2150. Voyager 1 flew past Jupiter in March 1979 and Saturn in November 1980, sending back breathtaking discoveries that rewrote the textbooks. It revealed Jupiter's faint rings for the first time, spotted active volcanoes on the moon Io, the first active volcano seen anywhere besides Earth, and showed that Io has over 400 volcanoes today, many still erupting. Then it raced on to Saturn, capturing razor-sharp views of its spectacular rings, discovering shepherd moons that herd and shape those rings, and confirming Titan has a thick nitrogen-rich atmosphere, 90% nitrogen, thicker than Earth's. After its planetary tour, Voyager 1 kept going outward. Voyager 2, on a different path, visited Uranus in 1986 and Neptune in 1989, places Voyager 1 never reached, and gave us the only close-up photos we have of those ice giants to this day. Voyager 2 discovered 10 new moons at Uranus, dark rings, and at Neptune found the Great Dark Spot and geysers on Triton. After their main missions, both Voyagers continued their journey into the unknown. Even though Voyager 2 launched first, Voyager 1 is now farther out because it's traveling faster, about 17 kilometers per second versus Voyager 2's 15.3 kilometers per second. That 1.7 kilometers per second difference adds up fast. In just 1 second, Voyager 1 pulls 0.9 miles ahead. Both spacecraft have now left the heliosphere, the giant bubble of solar wind that protects our solar system. Voyager 1 crossed the boundary on August 25, 2012. Voyager 2 followed on November 5, 2018. Data from the moment showed solar particles dropping sharply while interstellar particles suddenly surged. The heliosphere marks the Sun's direct influence. But our solar system is much bigger. The Oort cloud of icy comets lies far beyond. It will take Voyager another 300 years just to reach the inner edge of the Oort cloud and about 30,000 years to cross it completely. So how do we still talk to them across these cosmic distances? Each Voyager carries a 12-foot wide, 3.7-meter high-gain dish antenna that beams an incredibly narrow radio signal using only 22 watts of power, about as much as a dim household light bulb. Right now, a one-way signal takes roughly 23.5 hours to reach Earth. For comparison, light takes just over a second to the Moon and about 20 minutes to Mars. Radio waves fade according to the inverse square law, so by the time Voyager's signal arrives, it's weaker than 1/1,000,000th of a watt. NASA catches these whispers with the Deep Space Network. 3 giant 230-foot, 70-meter antennas in California, Spain, and Australia. One is always pointed at the Voyagers, giving us 24/7 coverage. Power is the real challenge. Far from the Sun, solar panels are useless. Instead, both Voyagers use radioisotope thermoelectric generators, nuclear batteries that turn heat from decaying plutonium-238 into electricity. At launch they produced over 470 watts each. Nearly 49 years later, output has dropped to around 250 watts and keeps falling about 4 watts per year. To stretch every drop of power, engineers have gradually turned off non-essential systems, including cameras after the famous pale blue dot photo in 1990. Earth is a tiny speck from nearly 4 billion miles away. Carl Sagan famously said of that image, "Look again at that dot. That's here. That's home. That's us." Today, only a handful of instruments remain active on Voyager 1, mainly the magnetometer and plasma wave subsystem studying the interstellar environment. Each probe also carries something truly special: the Golden Record, a 12-inch gold-plated copper disc like a cosmic time capsule. It holds 116 images of Earth, greetings in 55 languages, sounds of nature, whales, and 90 minutes of music from Bach to Chuck Berry and traditional songs from around the world. Instructions on the cover show how to play it, plus a pulsar map pinpointing our sun. It's designed to last 1 billion years or more, possibly 5 billion, waiting for any future finder. The Voyagers have faced real drama too. In 2023, Voyager 2's antenna drifted just 2 degrees off, enough at billions of miles to go silent. But it had an automatic backup routine that repointed it, and contact returned after weeks. Voyager 1 had a 2022 software glitch that sent data from a dead computer. NASA fixed it months later with clever commands. Thrusters that keep the antenna aimed are clogging with residue after decades, so engineers updated software to fire them longer but less often, buying about 5 extra years. NASA expects communication to end around 2036 at the latest, though careful power management might let science data flow into the early 2030s. After that, the probes will coast silently through interstellar space forever. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of the star Gliese 445. The golden records may outlive Earth itself. Launched for a 5-year mission, these 1970s marvels with less computing power than a modern smartphone have operated almost 49 years, and they're still teaching us about the universe. Voyager 1 and 2 are true ambassadors of humanity, carrying our story into the stars. What an incredible legacy!